The given set of vectors the given set of basis vectors basis set is this 1 0 1 1 1 1 and 1 3 4. We are renaming this. First we are considering alpha 1, this is equal to this vector 1 0 1 1 0 1. Next we are considering alpha 2, this is equal to the second vector of the basis set 1 1 1 1 1 1. And third we are considering this alpha 3 vector, this third member 1 3 4 of this basis set. We are writing this alpha 3 equal to 1 3 4. Again we are renaming this alpha 1 vector as a beta 1. That means we are taking beta 1 equal to alpha 1. We are considering this. Now we are constructing another vector beta 2 in such a form. Alpha 2 vector, alpha 2 is the second member of the basis set. Alpha 2 beta 2 vector equal to alpha 2 vector minus C1 into beta 1 vector. Beta 1 equal to alpha 1, which we have considered. And C1 is the scalar component of this alpha 2 vector along the vector beta 1. We everybody are already familiar with the scalar component. The C1 being the scalar component of the alpha 2 vector, C1 being the scalar component of this alpha 2 vector along the vector beta 1, we are using this formula. C1 equal to the inner product of alpha 2 and beta 1. C1 is the scalar component of the alpha 2 vector along the vector beta 1. So we are writing C1 equal to the inner product of alpha 2 beta 1 divided by the inner product of beta 1 and beta 1. And we also know how to calculate this inner product. We have calculated the inner product of alpha to beta 1. Beta 1 is basically the vector alpha 1 and alpha 2 is this vector. So the inner product of this alpha 2 and this beta 1 vector would be 1 into 1 1 into 1, we have written here 1 into 1 plus 1 into 0 1 into 0 plus 1 into 1 plus 1 into 1 divided by the inner product of beta 1 beta 1 equal to this vector. So first will be 1 square, second plus 0 square plus third plus 1 square. So we have written here 1 square plus 0 square plus 1 square. And after calculation we have the value of C1 is equal to 1. So beta 2 equal to alpha 2 minus C1 beta 1. We are substituting the value of C1 and the value of C1 is 1. So beta 2 equal to alpha 2 minus beta 1. This is alpha 2 vector and this is beta 1 vector. So after component wise subtraction, this would be first component is 1 minus 1 0, second component is 1 minus 0, that is 1, and the third component is 1 minus 1, that is 0. So we have beta 2 vector equal to 0 1 0 0 1 0, and this beta 2 vector would be orthogonal to this alpha 1 vector. This alpha 1 vector, if you check, how to check the one vector is orthogonal to another using the similar process. You shall have that this vector beta 2 is orthogonal to the vector alpha 1. Okay, beta 2 vector is the linear combination of alpha 2 and beta 1 vector. So if we consider the linear span of beta 1 and beta 2 vector, this would be equal to linear span of alpha 1 and alpha 2 vector. Beta 1 equal to alpha 1 vector, and beta 2 we have so constructed alpha 2 minus beta 1 after substitution of the value. After substitution the value of C1, alpha 2 minus C1, and obviously this is the linear combination of alpha 2 and beta 1 vector. This is equal to beta 2. Here we are considering the linear span of beta 1 and beta 2 vector. Actually beta 1 is alpha 1 and beta 2 being the linear combination of alpha 2 and beta 1. This actually would be linear span of alpha 1 and alpha 2. In place of beta 1 we have written alpha 1, and in place of beta 2 we have written alpha 2. How this happens, I am skipping the theoretical discussion here and saying you merely to keep it in your remembrance. Okay.